Hello friends, this is Yusuf here. Today we are going to see the most requested video about the ILE concepts in RPG programming. So we are doing RPG coding for several years, but still many of us didn't know what actually the ILE concept is all about and how to use that concept in our day-to-day activities. In this video we are going to learn everything from basics. So after this video you should be able to implement the ILE concepts in your programming. Okay, so ILE concepts are basically the activation groups, procedures and subprocedures, programs, modules, service programs and binding directories and so on. So let's see everything one by one. So before we move into it, I want to go from a subroutine to a subprocedure and so on. So typically I'm going to create a program. Okay, my program will be SAMP001 RPGLE. Okay, so this program is all about converting a string to uppercase and to a lowercase. Okay, so let me quickly read the code. Okay, I'm having two variables. One is string, which is the input string for our program, which is having value test string, and we are going to get the output in a variable called new string 1. Okay, that will be either uppercase or lowercase. So for that, in our traditional way, I'm going to using xlate method. So for that, what we need a constant uppercase. Okay, this will be our constant and will be having the value maybe okay, so we are having two constants, uppercase and lowercase, and directly we start writing the free format. And okay, so you all know the basic code will be new str1 is equals to xlate. We are going to convert from on to, so if any lower case is there, then convert that to upper case from the string called string. This will be our code. If we display the new str1, it should display the correct uppercase value. So typically this will be a generic program which is converting a lowercase to uppercase. Okay, then there comes the concept of subroutines. So you might be knowing we can have a piece of code as a subroutine in the program itself, and that can be called anytime you want. So what I'm going to do, I'm going to create a subroutine by begin subroutine to upper. Okay, so end SR. Inside that, what I'm going to do, I'm going to have this string the conversion cut paste. So now we have moved our code which is converting from lowercase to uppercase into a subroutine, and here we will normally do a execute subroutine to upper. Okay, so this what we will do, it will execute the subroutine, and in subroutine whatever the code we have, that will get executed. Fine. So first quickly compile this and then show you how it works. Okay, I'm in debug mode. So we can see that when the execute subroutine is executing, so it's coming directly inside, and then it's executing the value, and then if you see the value, it will be test string, it is all caps. Okay, so everybody knows about this subroutine concept, but now what we are going to see is we are going to make this subroutine as a subprocedure. So what is the advantage of making this as a subprocedure? First of all, so this subroutine is actually kind of inside the same program. So this new string is a variable which is already defined in the main program variable, and the same is being used. And actually we are not writing any new code. Instead we are just splitting the whole code into small chunks, and then whenever we are required, we are executing based on a executing whenever we require, we are executing subroutines. Okay, but if it is a subprocedure, it will act as a separate program. So when I say separate program, it will get a input and it can return a output. Okay, so let's see how to do that. So first of all, we need to define the subprocedure in the main program. So I'm going to define a subprocedure my procedure name will be, you can have the same name, 2 underscore upper, take F4, and this should be a procedure, so PR. Okay. Okay, next is, this is going to have one parameter. I'm going to have the parameter name string, take F4, and the length of the string is 50A. Okay, so this is the definition, and since this is going to return as a value, so we need to define the return variable here. So by specifying a data type here, it understands that this procedure is going to return a 50 length of character, return back to the calling program. Okay, and instead of, okay, let's write the sub procedure now. This is called the definition. Okay, procedure definition. Okay, so let's come here. So now it's not no more our subroutine, so we are going to write by P means procedure. Okay, and our procedure name is 2 underscore upper, take F4, and it's a B means begin. Okay, and this will be ending here, giving E. Okay, fine. So next thing is what? So normally, as I say, it's going to get the input in RPG programming, we'll get the input using star entry P list, right? So here, how we need to receive it, like 2 underscore upper. So equivalent of that is actually called, sorry, this should be D. Okay, equivalent of that should be PI, called program entry. Okay, so that is a program entry, and that's going to have a variable string, and the length will be 50 of A. Okay, so next is, again, this is going to return as a value, so it's a 50A. Okay, so again, this you can see the same thing as a declaration. What we have done. Okay, it's a procedure declaration, it's procedure definition. So here we have put PR because here we are just telling this main program that we are going to call a procedure. Okay, and the definition is given here, and inside the procedure we need to begin the procedure, and then we need to give a PI for program entry, and then this will be our input and this will be our output. Okay, now let's write the code inside. So now we don't want this begin subroutine and end subroutine, delete it. Okay, now as I said, this is going to be a separate program, so this will not be knowing the variables used in the calling program. Okay, so here I'm going to make this a new variable called new string, and then here I'm going to define the new string, take F4. This will be a standalone variable and having length 50A. Okay, so then in this variable we are actually converting the lowercase into uppercase based on the input string. Okay, and then the value will be in new string. Finally, what we are going to do, we are going to return the new str. Okay, fine. So we are done with the procedure, and here, so it's not a subroutine, so it's going to be a procedure. So, and a procedure called 2 underscore upper is going to have the input called any string. Okay, and it's going to return a value. We are going to receive it under new str1. Okay, so on the whole, let's go through the program. So new str1 is actually a variable in the main program. So that new str1 is going to get the output of the procedure 2 upper, and 2 upper we are passing the input as string. Okay, and then finally displaying the new string. In 2 upper procedure, we are receiving this string as an input, and then we are returning a 50 character output. That 50 character output we are just defining inside a standalone variable, and then we are converting into the uppercase, then we are returning it. So this is a sample sub procedure code. Okay, fine. Now let's compile this. So file. So if, as usual, if you try to compile using 14, okay, you will be getting an error 30. Okay, this will be saying that default activation group no is not allowed with procedures inside. Okay, so when we didn't give anything, it automatically, if 14A4, it will take default activation group. Okay, sorry, default activation group as yes, it will defaultly take the activation group as yes, which means it's not a ILE program. Okay, so for this what we need to do, we need to compile this as a module by taking 15. Okay, take a 4. We can give again the debugging options you want. So now this has been compiled as a module. Okay, now to use the programs or the coding available inside the module, we need to create a program. So for that only we are using a create PGM. Okay, and then the us1 sam001 take a 4. So we are going to bind the module we just created 01 us enter. So we have created a program which is binded by the module called sam001. So now if you try to debug it, call sam001. So now you can see this is the main procedure actually coming inside, and here I am pressing shift F10 because this is actually going to be this will act like a new program. So shift F10. Okay, now it's going to the to upper routine F10. So it's assigning the value, then it's returning a value, and then we get the value in the new string. Okay, so now you would have got some idea how to convert a sub routine into a sub procedure. There are really a lot of advantages over sub procedures, so we need to start doing it. So next, what is the actual benefit of making a sub procedure? See, if we have many procedures, we can have a single module which consists of many procedures inside. Okay, and then we can have that as a single module, and then we can write n number of programs in which we can bind this module into all the programs, so that all the programs will be able to use the code written inside the module. So if you are a bit confused, so let's see this with a sample example. Okay, so I'm going to demonstrate you with the same example sam001. So here we said this is the procedure, okay, and defined inside the main program. So this will be visible only to this program, but if you want to make this program available outside the other programs, we need to make the procedure as export. Okay, by giving export, what it says that we are exporting this particular procedure, okay, outside the module so that others can use. So but I have just changed this to export, and then I'm going to recompile this again. File 15. Fine. So now we have just created a module called SAMP001 which is having a procedure called to_upper which is exportable. Okay, now I'm going to create another program sam002, okay, and I'm going to bind that sam002 with this module sam001, and I'm going to use this procedure which is available inside the sam001 into my new program sam002. Let's do it. So I'm going to create a new program sam002 or PGLE. Okay, fine. See here, first thing first, so this program needs to know the declaration. Okay, so for that again we need to declare what we are going to do. So first here we will say we are going to have a procedure called to_upper. It's a procedure and it's going to have a return length of 50a. Okay, and it's going to have a string of input going to have a 50 length a. So we have defined the procedure here. Fine. So now to test this functionality, what we are going to do, we'll write the code, and I'm just going to say variable is equals to upper of hi, how are you, and then I'm just displaying variable, and then I'm just okay. Here we need to notice one important point. So first of all, we have been defined it as a procedure, right? So when we say it's a procedure, it has to match the parameter condition. Okay, so we say we are going to give an input of length 50. It means we have to give the input of length 50. If you pass something like this, it will not get understand. First of all, let's see whether that's working or not. So this is it. So we are going to have this is the declaration we have, and then we are going to use that into a variable. We need to define the variable. Yes, that's true. So let's define the variable called var. This should be a standalone variable of length 50a. Okay, so let us see how this works. Okay, now when I try to compile as a module, right, I get the error parameter cannot be passed by reference when it is called during the call. So this is because we didn't match the exact the data type condition. Let me change the program. Okay, I have now included variable 1 and variable 2, and both are matching with our declaration. Okay, and then variable 1 is going to have a string, and then we are going to convert into uppercase, and then the result will be in variable 2, and then we are just displaying it. So now we need to compile this as a module first. Okay, now we have compiled this as a module, but the procedure which we are going to use, which is the 2 upper, is there in the SAMP001. Okay, so we can see using display module OUS1 SAMP001. So if you go press enter, okay, we can see that SAMP001 is actually having the 2 procedures which we have. One is the main procedure and one is the sub procedure. So we need to bind this SAMP001 with SAMP002, then only we can use the procedure in the calling program. So for this, what we are going to do, we are going to do create PGM US1 SAMP002 take a 4. So first we are going to have SAMP002 as a module and also SAMP001 as a module. So now it's created. Now if we call SAMP002, we can actually see the text is been converted. Okay, so this is the way of using module and program combining together. And then there comes the concept of service program. So service programs are nothing but, okay, service program can have one or many modules. Okay, so a module can have one or more procedures or sub procedures, and we can create a module 1, module 2, etc., and all the modules we can combine together and then create a service program, so that whatever the program we are going to write in future, we can just bind the service program to the actual program, so that all the modules and sub procedures can be accessible from the new program. Okay, so I'm just going to create a module now. When I say module, it's a list of procedures or sub procedures. So I'm going to call it as module 1. It's RPGLE. Okay, so the name is module 1, but still this is RPGLE code. Okay, so here let me quickly write the code. Okay, so here what I have done, the same 2 upper procedure, and we have created a source for module, and then we are having a procedure, same like first we'll have a declaration, then we'll have a procedure start and end, in between we have the code, and we exported it. Okay, so similarly I'm going to have one more thing, which is let's create a tool lawyer. Okay, so again it follows the same pattern. It will get a string and it will try to return a output with all lowercase characters. So for this, again we need to replicate something like this. So that is okay, let's give a space. Okay, so it's going to be too low here and it's exported, and too low here, same stuff, and then here we are going to convert from uppercase to lowercase. Okay, and then we need to end the procedure. Okay, So fine, so maybe I can give you one more thing. So another thing is okay, so today we'll finish with these two. So now let's compare this. Okay, module 1 is a source member which contains the two different procedures called 2 underscore upper and 2 underscore lower, but it is not having any main routine. Okay, so we can just take 15 and compile this. Okay, so the error is due to the constant is missing. So let's quickly add the constants. I'm too lazy. Okay, so we need to add that inside here. Okay, so since this will act as a separate program, right? So inside the program we need to have the required constants available, and similarly we should have the required constant in this procedure also. Okay, so now let's compare this. Compiled. So now we have a module called module 1 available with two procedures exported. Display module US1 module 1. Okay, so this is having two procedures exported. So now if we create any program with binding this module, automatically we can access these procedures. But if you have 10 different modules, okay, so if you have 10 different modules, we cannot do a create PGM and then we keep on adding the module 1, module 2, module 3. Okay, so that is not necessary. So for this only we are having the service program concept. So we are going to create a service program, take F4, and we have to give any name. So I'm going to tell as test SRV PGM in my library. I'm going to create. Okay, and then it asks which module. So I'm going to say it's module 1 and from this library, and I'm going to say you can export all the procedures inside the module. So here also you can see you can add many more modules you want. Okay, so now let's give enter, and the service program is created. So display SRV PGM US1 test SRV PGM. So here what we are seeing here is, so this test service program, which is a service program, contains a module 1, and then that is exported with two subprocedures. Now we are going to create another program which is SAMP003. Oh, I don't know whether I give RPG or not. Let me check. Is text. Delete it. F6 SAMP003 RPG. Okay, so here let me quickly copy paste the code. Okay, so this is our new program SAMP003. So as usual we need to define the procedures first, what we are going to use. So we have defined the procedures. So the another point is, if you want to okay, so we have defined the procedures. Next is we are having a two variables, input string and output string, and we have defined the value in input string, and we are using the directly the procedures 2 underscore upper and 2 underscore lower. It's a typo. Okay, so let's see, this will be upper, should be displayed in upper string, and it will be lower, should be displaying in the lower string. Okay, and finally we need to end the program. INLR equals to string. Okay, got it. So now this is a program which is going to use the procedures, but what we are going to do is, okay, again we are going to compile this as a first module 15 compiled. Now while create PGM, there was one SAMP003 F4. Instead of module, we are going to add F10 and page down service program test SRV PGM US1. This is a command actually. So we are going to create a program for SAMP003 with the service program binded. Let's see, created. So now if we call SAMP003, we should be able to see it will be upper, and we should be able to see it will be lower. So now you get the idea, right? Okay, so like this we can have n number of procedures, okay, available inside a single module, and then we can convert n number of modules into a service program, and we can just bind the service program with our new program, so that these routines can be easily accessible into the programs. Okay, now the last tip what I'm going to tell is, we can see everywhere we need to define the procedure, and it's always being the same. Okay, so for this reason, what the people will do, they will have this procedure in a separate source file, and they will just try to include it. So what I'm trying to say is, actually I'm just going to copy this. Okay, this line of code is our declaration anywhere we see. So I'm going to create a PR type, prototype PR type RBGLE. So here I'm just going to give these values. Okay, that's it. I'm going to save this. Okay, and inside my module I'm not going to do any of these. I'm just going to slash include. I'm going to include dev yus1 all source 2, which is my source file, comma PR type. So once I included that, I no longer require this. Okay, let's save this. And also in our program, okay, so here we have given the declaration. Instead of this, we can have include the OS1 all source 2 comma PR type. Okay, so this should work the same way. Okay, as usual, we have changed this. So let's compile as a module. It should work fine. And also SAM3 compile as module. Okay, and then the command we just used, oh, it's gone. Where is the command? Yeah, here is the command. Okay, yes, created. And if you call SAM003, yeah, we should be able to see it will be upper lower. Okay, now we would have some idea about modules, procedures and service programs, and finally we are going to see binding directory. Okay, so binding directory is another cool stuff. So here we can see one pain point is, we are creating as a module, and then we are, I think, issuing a create PGM to create the program. We can do these two steps in a single step using a binding directory. So here what we are going to do is, again, how the service program is the concept of including multiple modules into single service program. Like that we can combine module or a service program into a binding directory. Okay, so I'm going to create a binding directory, a OS1 test bnd directory. Okay, take F4. Okay, no options needed, enter. So now we have created a binding directory. I need to add the things into it. So add binding directory entry. Okay, take F4. So I'm going to, okay, it will ask test bnd clear OS1. This is my binding directory, and then I'm going to add test srv pgm, which is our service program, in my library dev OS1. Okay, like this. And you can also add any modules you want. Okay, this we can change. Take F4. It can be either a service program or a module. So now I'm going to create a binding directory which contains only one service program. So enter. So display binding directory dev OS1 test bnd directory. So this is having only one service program, and automatically the service program will be including a module, and then the module is having the procedures 2 underscore upper and 2 underscore lower. Fine. So how this will be useful, I am showing you. So I am taking this SAM003 file, I am giving a new name SAMP004. This is something like file save as. Okay, enter. So now it's created a SAM004. It's a copy of SAM003. I'm not going to change anything, okay, but I'm just going to include a statement here. Default activation group is no, and activation group is new. And then importantly, binding directory is the OUS1 test bind directory. Okay, now I'm not going to take 15, I'm not going to compile this as a module, I'm just going to take 14, okay, and then compile it. Ta-da! It works. Okay, so if you want to test strdbg calls, okay, see, I'm here, I pressed F10. Now I'm going to press shift F10. It is okay, sorry, here shift F10. So it will go to the service program actually. So we didn't compile the service program with source, debugging view as source. Anyway, F12. So you can see the values are printed. So binding directory is something which is able to hold many modules and service programs, and we can directly use that binding directory in the header specification of your program, and then it should work as it is. Okay, so thanks for watching for I think more than 30 minutes. So but I hope you really get some idea of how we are using the module, service programs, procedures, blah 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 as ILE concepts in our day-to-day activities. I'll try to cover a few more steps in the coming videos. Thanks for watching.